everyone, this is Chinnaiah Kalpana here. In this video we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from f of x square plus y square plus z square comma xy plus z equal to 0 by eliminating f. So we are given a relation f of some u and v equal to 0 where f is the arbitrary function, and we are asked to form a partial differential equation by eliminating this f, right? Let's see. So here we can apply any of these three, or you may get another method also, but in this video we are going to try the first two. I'll explain the first one, and at the end of the video I'll just show the solution using this method, and I'll show this method in the next video. Okay, let's see. Given f of x square plus y square plus z square xy plus z equal to 0, consider some equation number 1. Now let's rewrite it as equation 1 as, I'll take u equal to some g of xy plus z, consider as equation number 2. Okay, u equal to g of v, just applying this method. Okay, now we'll partially differentiate it with respect to x and also with respect to y. First, as usual, we'll just differentiate it with respect to x, and later we'll go for with respect to y. So this is our equation 1 and this is our equation number 2. Partially differentiating to with respect to x. Okay, you can just apply dou by dou x on both sides of the equation 2. I'm just applying dou by dou x on both sides of 2 to make it easy, in order to avoid mistakes otherwise. Okay, since we are partially differentiating with respect to x, so we'll treat y as constant here. This gives us dou by dou x of first term, dou by dou x of second term. So you can also do directly instead of increasing the number of steps. You can just do directly, but many feel confused, okay, if I do, or if I just jump to the direct step. So I am giving little explanation here. You can just skip this out. Now partial derivative of g of xy plus z is g dash of xy plus z into inner derivative, that is dou by dou x of xy plus z, right? This gives us partial derivative of x square is 2x plus partial derivative of y square with respect to x is 0 plus partial derivative of z square with respect to x is 2z into dou z by dou x. This is equal to g dash of xy plus z into inner derivative dou by dou x of xy plus dou by dou x of z. So here we have a constant y, right? We can write this as y into dou by dou x of x. Okay, or you can just do directly 2z into, since we have a notation dou z by dou x is p, since dou z by dou x equal to p, we can just replace it by notation p equal to g dash, is nothing but g dash of xy plus z into, here we can write this as y into dou by dou x of x plus partial derivative of z with respect to x is dou z by dou x. Here also we'll just replace this dou z by dou x by p, and this gives us 2x plus 2zp equal to g dash of xy plus z into y into partial derivative of x with respect to x is 1 plus, just replace it by p, you'll get plus p, right? Finally you'll get 2x plus 2zp equal to g dash of xy plus z into y into 1y plus p, or you can just take 2 common from these two terms if you feel we can just cancel 2 later. Okay, we exactly know that 2 gets cancelled, then you can just take 2 common. Okay, I'll take 2 common here because I know what's going to happen. So I'm taking 2 common from the 2 steps of RHS, and this results to equation number 3. Okay, now let's partially differentiate equation 2 with respect to y. Fine, now let's partially differentiate equation 2 with respect to y, right? Partially differentiating two with respect to y, just apply dou by dou y on both sides of 2. Here we are partially differentiating with respect to y, so we'll treat x as constant. Partial derivative of first term plus partial derivative of second term plus partial derivative of third term equal to partial derivative of g of xy plus z is g dash of xy plus z into inner derivative, that is dou by dou y of xy plus z. Since we are partially differentiating with respect to y, so here x is treated as constant, right? This gives us partial derivative of a constant with respect to y is 0 plus partial derivative of y squared with respect to y is 2y plus partial derivative of z squared with respect to y is 2z into dou z by dou y equal to g dash of xy plus z into partial derivative of first term plus partial derivative of second term, right? This gives us 2y plus 2z into, since we have a notation, dou z by dou y equal to q, right? Now we'll just replace it by q, you'll get 2zq is equal to g dash of xy plus z into, here we can take x as constant and we can write it as x into dou by dou y of y plus partial derivative of z with respect to y is dou z by dou y. Again we'll replace it by a notation q, and here we can take 2 common, you'll get 2 times y plus zq equal to g dash of xy plus z into x times partial derivative of y with respect to y is 1 plus, we'll just replace it by q, right? And this gives us 2 times y plus zq equal to g dash of xy plus z into x into 1 x plus q. Consider as equation number 4. Now we have equation 4, 2 times y plus zq equal to g dash of xy plus z into x plus q, right? Now observe equation 3 and 4, which involves g dash of xy plus z, right? We can just eliminate z dash from this 3 and 4 using 3 by 4. Let's see that. Now using 3 by 4, we'll just eliminate g dash, right? LHS of 3 by LHS of 4, RHS of 3 by RHS of 4, where 2 gets cancelled, g dash gets cancelled, and this gives us x plus zp by y plus zq equal to y plus p by x plus q. Now make a cross multiplication to simplify it. Right, now this gives us x into x, x square, zp into x, pxz, x into q, xq, zp into q, pqz equal to y into y, y square plus py plus y into zq, yzq or qzy plus p into zq, pqz. Here we can cancel pqz and this results to x square plus pxz plus xq equal to y square plus py plus yzq, right? Now we'll write the terms that involves p and q in LHS part and the terms that does not involve p and q in the RHS part. So we'll just bring these two terms to LHS and take this x square to RHS. We'll get pxz plus xq minus py. This becomes yzq equal to, this remains the same, y square, and we'll just take x square to RHS. It becomes minus x square, right? Now take p common from these two terms. We'll get p times xz minus y, and now take minus q common from these two terms. Okay, you'll take minus q common, then you'll get minus q times yz minus x, right, which gives us minus qyz minus into minus plus xq, which is the same, right? Why I took minus q common from these two terms is just to maintain the pattern. Here we have xz minus y. If you take minus q common, you can get in terms of z minus x, right? Fine. Which is the required partial differential equation. Therefore, p times xz minus y minus q times yz minus x equal to y square minus x square is the required partial differential equation. This completes the problem. Now let's see how to find the solution using v equal to g of u. Okay. Well, so this is how we'll solve the problem using v equal to g of u. So you'll get the same answer. Fine. So we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.